How Iran is extracting uranium from the earth? Well, its stockpile of 60% enriched uranium has now reached over 400 kilograms. Because this high-purity material is considered only a short technical step away from the 90% enrichment level required for a nuclear weapon. This is uranium ore, which Iran harvested using a drill that pulls a reamer up through a pilot hole to widen it. The broken ore then falls into what is known as an extraction chamber. A remotely operated bulldozer picks up the uranium rock. Operating the vehicle from a distance is essential to keep the operator safe from falling rock hazards. But what happens after the uranium is collected? Fast forward, the uranium is condensed, ground, and then placed into a centrifuge for further enrichment. Everyone talks about centrifuge enrichment, but how does it actually work? Let's explore the process through this visualization. The green dots represent uranium-238 atoms, while the blue dots represent the concentration of uranium-235 atoms. What does natural uranium look like at the atomic level? This first batch is natural uranium, which contains only 0.7% uranium-235. In this imagery, we see 5% low-enriched uranium, which is the standard used for commercial nuclear power plants. And what about the material used for weapons? Finally, we have weapons-grade uranium, which contains 90% uranium-235. As you can see, almost all the uranium-238 has been removed and replaced by the blue uranium-235 atoms. Let's show how this is extracted through super simplified animation. The centrifuge consists of a high-grade tube with a spinning motor at the bottom and a feeding tube at the top. Uranium is fed into the centrifuge as a gas called uranium hexafluoride. As the motor spins at high speed, the heavier uranium-238 is separated from the lighter uranium-235 using centrifugal force. The uranium-235 floats to the top and is collected at this section of the centrifuge, while the heavier uranium-238 in the color green falls to the bottom of the centrifuge and the enrichment process is complete. If the nuclear enrichment are 90% pure and compressed into rods, this is how it might work. And the most important part is the uranium-235 hollow projectile rings. It weighs around 84 pounds or 38.4 kilograms. While at the front is the uranium target rings that weigh around 56.2 pounds or 25.6 kilograms. Closely note, as it is very important to understand, the projectile ring slugs are hollowed and designed for the target rings to enter. These are the 3 electric gun primers. The primer is the device responsible for initiating the propellant combustion located here, also known as the cordite or conventional charge, that will push this projectile at an explosive force. All these mechanisms and parts are encased in a 6.5-inch or 170mm smoothbore gun barrel. Moving to the front, this is the impact-absorbing anvil. Just above it is the tungsten carbide plug. These are the 4 polonium initiators placed on the tungsten carbide. They are kept to make sure there will be a nuclear chain reaction when it is dropped and activated. Let's simplify this through these animations. Once the correct height is sensed, the firing switch activates. The 3 Navy gun primers ignite the charge, consisting of 4 soap powder bags, each containing 2 pounds or 0.9 kilograms of cordite. The uranium projectile is launched at 300 meters per second. At this point, 4 polonium initiators placed on the tungsten carbide initiate nuclear fission reactions. In a milliseconds, there will be an explosion damaging buildings and killing people by the thousands. Moving back to the 3 main enrichment plant, namely Fordo, Natanz, and Isfahan. Iran secretly relocated its 400 kilogram stockpile of 60% enriched uranium to an undisclosed location before the U.S. airstrikes on its nuclear facilities. Unusual truck activity at Fordo. In the days leading up to the strikes, satellite imagery revealed a convoy of 16 cargo trucks lined up along the main road leading to the tunnel entrance of the Fordo fuel enrichment plant. This was highly unusual, as such large-scale vehicle activity had not been observed before, suggesting preparations to transport sensitive materials. The following day, most of the trucks had disappeared from the site, while a few were spotted about a kilometer away from the tunnel entrance. The scale and timing of this movement strongly indicated the removal of critical assets, most likely the enriched uranium. Tunnel sealing operations. Additional satellite images showed trucks and bulldozers positioned near the main tunnel entrances. Some vehicles appeared to be involved in sealing off the tunnels, likely in an effort to prevent inspection or further attacks. These actions suggest a coordinated effort to secure or hide what had been stored inside. According to the International Atomic Energy Agency and U.S. intelligence, the underground enrichment halls and tunnel entrances sustained very significant damage. Some tunnels will reportedly collapse or backfilled in anticipation of an airstrike. Above-ground infrastructure, including power systems and facilities linked to uranium conversion and metal production, was heavily damaged or destroyed. Leaked reports from the U.S. Defense Intelligence Agency based on initial battle damage assessments by U.S. Central Command confirm the credibility of these findings. However, the assessments also note that the strikes did not eliminate the core components of Iran's nuclear program. Most centrifuges and enriched uranium stockpiles survived intact. As a result, the DI estimates that while Iran's nuclear ambitions have been delayed, they have only been set back by a few months, not dismantled. But let's take a look at the possible scenarios where they have hidden these nuclear centrifuges. Evidence and expert analysis suggest Iran may have moved nuclear material from Fordo to several possible locations. One likely option is the underground tunnel network at sites like the Isfahan nuclear complex, which reportedly remain intact after recent airstrikes. Natanz, with its history of underground construction, could also house some of the material. Major nuclear facilities like Isfahan and Natanz have the capacity to store such material, even after partial damage. Iran may also have relocated it to secret or undeclared sites, including military bases like Parchin or unknown underground bunkers. Dispersing the material across hidden locations would reduce the risk of total loss. Now moving back to Fordo, let's take a look at why this nuclear enrichment site is so hard to destroy. Fordo is protected by a complex network of defenses, including 6 tunnel entrances leading into its underground uranium enrichment facility. The most critical parts of the site, specifically the enrichment infrastructure, are buried deep inside a tunnel approximately 200 meters long, carved directly into the side of a mountain. The main enrichment chamber is believed to sit directly beneath the mountain ridgeline, hidden under a massive layer of rock. From the tunnel entrance to the chamber, the distance spans roughly 200 meters. The terrain itself adds another layer of defense. It starts off with a gentle slope near the tunnel entrances, but becomes significantly steeper about 160 meters from the ridge, providing natural protection from overhead strikes. And here's where it becomes even more challenging. If the enrichment chamber sits at the same elevation as the tunnel entrances, it's shielded by approximately 40 meters of solid rock when approached from narrow vertical angles, around 25 degrees. A bomb dropped directly from above or even at a 40-degree off-axis angle, as would be typical for a high-altitude strike from a subsonic B-2 bomber, would need to break through up to 40 meters of dense mountain rock to reach its target. To overcome this, the U.S. deployed 6 B-2 Spirit bombers, each armed with GBU-57 massive ordnance penetrators, deep penetrating bunker buster bombs designed for hardened targets like Fordo. These strikes targeted the mountain ridge directly above the tunnel network and underground enrichment halls, aiming to penetrate the fortified layers and disrupt Iran's nuclear operations. The B-2s also targeted at least 6 of the known tunnel entrances leading into the facility. Post-strike satellite imagery, along with assessments from weapons experts, confirmed that at least 3 of the 4 main entrances sustained significant damage. Large craters were visible near these access points, indicating a direct hit and probable destruction to the facility's internal infrastructure. We make original videos from scratch, so please do subscribe and hit the notification bell for more videos.